Okay, in this problem we're going to approximate propagated air. Before I do that, I need to mention that propagated air is the change in x, or the change in y. So we know that change in y is approximately dy. So what we're going to be doing is we're going to be taking a derivative to figure out the approximate propagated air. The measurements of the base of an altitude, the base and altitude of a triangle are found to be 36 and 50 centimeters respectively. So what I now know is that my base is 36 and my height, my altitude is 50. The possible air in each measurement is 0.25. So each measurement, my dBs is what I'm going to call those, is plus or minus 0.25. We need to put plus or minus in front of there because it could be 0.5 above or 0.25 above or 0.25 below, so we need plus or minuses when we're talking about propagated air. And the same thing for my height. My altitude could be plus or minus 0.25 off as well. What we're going to do is we're going to compute the area. The area of a triangle is 1/2 base times height. I'm supposed to use the differentials to approximate the propagated air, so what I'm going to do is take the derivative to be able to use those differentials. So this is a product rule. I need to say first, and I'll count this as my first term here, and then h as my second term. So first times the derivative of the second, which would be dh, plus the second, h, times the derivative of the first, which would be 1/2 dB, because I'm taking the derivative of b. What that ends up giving me is that my dA, or my change in A, which is approximately dA, is equal to 1/2 times my base length, which was 36, times my propagated air, plus or minus 0.25, plus my height. My height is 50, times 1/2 times plus or minus 0.25. What this ends up giving me, when I type all this in a calculator, I would get 18 times plus or minus 0.25, plus half of 50 is 25, times plus or minus 0.25. This will give me the answer of plus or minus 10.75 centimeters squared.